Hello everyone, let us now discuss how can we solve this problem. Taking maximum energy from the mystic dungeon, right? So this description, I'll tell you how we can go through this. So instead, let us consider this description. You are given an array energy where each element represents the amount of energy you gain or loss if negative when you visit that position. So energy is just an array which contains negative and also positive elements. So if it is a positive, you gain the energy or you lost the energy if it is negative. Now you can start collecting energy from any index in the array. Once you start at index I, you can only move exactly k steps forward. Exactly, not less than or equal to, not less than, but exactly k steps forward. So I am here at this step. If I am at this step I, then I can only go to I plus k. That's it. From this I can go to I plus, wait a second. From this I can go to I plus 2k. That's how it works. So that's what is given here. That means your next position will be I plus k, I plus 2k, and so on until you move beyond the array. So your task is to find the maximum total energy you can collect by choosing the best starting position. I need to just know the best starting position. So what will be the brute force one, right? So the brute force approach, but before that, let me go with the examples. We can go three places ahead. So 0, 1, 2, 3, 4. Now I'm at 5. I can go only three places, right? So 5 plus minus 5. So it will give me like 0. Now I can go three places, right? So when I am at this 2, I can go to this 1. So 2 plus 1 is nothing but 3. When I am at minus 10, there is nothing like I can go to the 2 plus 3, fifth place, fifth index. I cannot go. So here it will be minus 10, and here starting at minus 5, here I am starting at 1. So the answer should be 3. Yes, it is 3. Now let us go with the next example, and then let us go with the what will be the brute force solution for this. Now I can go two places. So starting at minus 2, I can go to minus 1. So minus 2 minus 1 will give me minus 3. Now I can start at minus 3 and cannot go to the plus 2 place. So only minus 3 here. Then I can start at minus 1 and still only be there. So from this, minus 1 will be our answer. What will be the brute force approach? The brute force approach is start from every index, every index, and go to I plus k, I plus 2k, and so on until until the new index is less than n. Then only we can go and get the sum, and then and we need to update the answer every time, and at the last return the answer. So if you see, if I write the pseudocode for this, first I'll start with for loop I is equal to 0 and going till I is less than n, and from this I'll start with j is equal to I and j is less than n, and j uh, let us see like in a while loop. While j is less than n, j is nothing but I, right? So j plus is equal to k, right? So the sum plus is equal to energy of j. Now at the last, update the answer. Answer is equal to maximum of answer comma sum. Here the sum will be 0. Here it is I and the sum will be 0. So it is taking like this for loop will take big O of n, and this will also take big O of n. So totally big O of n into n will give me a time complexity of big O of n square. So let us optimize this. How can we optimize? right? So 5, 2, minus 10, minus 5, 1. 5, 2, minus 10, minus 5, 1. So what if I come from the end, right? So I start from here and then go to this and then, wait a second, not this, to this, and I'll stop there itself. I go to this and then stop here, right? But here itself and here itself, the answer is nothing but 1. Let me write it as db. I'll tell you why I'm naming it as db. So it is 1 itself. From this 1, this index, nothing but this index is nothing but 0, 1, 2, 3, 4. 4 plus k is nothing but 4 plus 3, 7. 7 is not less than n, right? So if it is not less than n, I'll just add 0. So if I add 0, no need to change anything. Now minus 5 is at index 3. So 3 plus 3 is 6. It is greater than n, right? So it will be minus 5 itself. Now I am at index 2. So 2 plus 3 is equal to 5, which is equal to n, but only from 0 to n minus 1 are present. So it will be same as minus 10. Now, when it comes to this index 1, 1 plus 3 is equal to 4. I have this 4. This 4 is storing this 1. So what I'll do, I'll add this 1 to 2, then I'll get 1 plus 2, nothing but 3. So from this, I am going to this, nothing but going in the backward direction. Now, I am at 5, where the index is 0. 0 plus 3 is nothing but 3. 0 plus 3 is nothing but 0 plus k, right? The current index I plus k. Now it is 3. At 3, I have minus 5. So this, not the one which I have here. We might get elements, right? So this will be added here, this will be added here. So and those sums or this dp initialization will be there in this dp, so this will be added. dp of I plus k will be added only if I plus k is less than n. If not, we will add just 0, right? So dp of I is equal to energy of I plus, if I plus k is less than n, then we will add dp of I plus k, if not 0. So for this, 5 minus 5 is 0. So what will be the answer from this? It will be 3. So we have solved this problem. Let me write the algorithm for this. First thing, what we are initializing, n is the size. Now initializing dp with n comma 0, and what will be the answer? Answer can be int minimum. Why? Because we can also get the uh, negative ones also as the answer. So for I is equal to n minus 1, I is greater than or equal to 0, I minus minus. What we'll do is dp of I is equal to energy of I plus, if I plus k is less than n, wait a second, I plus k is less than n, then add dp of I plus k. If not, I will add 0. That's it. At the last, return answer. But if you see, I'm not updating my answer. So answer is equal to maximum of answer comma dp of I. That's how I'll solve this problem and return the answer at the end. I have given the code in the description. Go and check it. So we are updating our answer 0, 3, minus 10, minus 5, 1. From this, the answer will be 3. So thanks for watching this video. Do like, share, and subscribe to my channel. Thank you.